Wetlands are classified as shown in this table. Example 3 says the hydronium ion concentration of a water sample from a wetland is 4.5 times 10 to the negative third. Classify this wetland. So we've got a formula that says the pH is equal to the opposite of the log of that hydronium ion concentration. So in this case, 4.5 times 10 to the negative third. So 1, 2, 3, let's think of this as opposite of log of 0.0045. So that becomes a calculator question. We're going to do opposite of the log of 0.0045 and get about 2.3. The pH is about 2.3. And so if you notice, 2.3 would put it into this category, less than or equal 3. So this is a bog. The loudness of sounds is measured in decibels. We first assign an intensity of I sub O to a very faint threshold sound. If a particular sound has intensity I, then the decibel rating D of this louder sound is given by the following formula. Find the decibel rating of a sound with intensity of 10 million IO. So the intensity is equal to that. So if we look at our formula, the decibels are equal to 10 times the log of the I value, which they gave me was 10 million I sub O over I sub O. So notice those IOs cancel out, and so we're looking at 10 times log of 10 million. 10 times log of 10 million. $70 decibels, or a decibel rating of 70. Here's a formula for a natural log. Natural log looks like ln. Find that button on your calculator. Ln is the natural log, and it is thought of as base e. It is a log base e. So natural log is one that comes up kind of a lot, but it's log base e. And you should notice when you find that button, it's probably, if you hit shift in that button, you've probably got the e button. So those things are definitely related. Natural log is log base e. So number 5 says use a calculator to find the values. Well, this is just straightforward calculator questions. So if we do natural log of e to the 4th, we just get 4. And that should make sense because natural log and e, a base e, those are inverses of each other, so those just cancel each other out, and so you're just getting 4. Part B says natural log of 341. Messy decimal is about 5.8319. I like to round to 4 decimal places. Natural log 0.06894 is about negative 2.6745. Okay, measuring the age of rocks. By measuring the amounts of potassium 40, it's K, and argon 40, A, in a rock, the age T of the rock in years can be found with this formula. Now you need to notice I made a typo in this, okay? This minus sign right here should really be a plus sign. So make sure you change that, otherwise you're not going to get the right answers. It's mainly just a calculator question, but let's make sure we can plug that in correctly. So number 6 says, how old is a rock sample in which A equals K? So it's kind of confusing, but if you notice over here in the formula it says A over K, right there, A over K, we need to pretty much make this look like that. So notice if you divided both sides by K, we would see an equivalent equation of A over K equals 1. So that's going to help because really all we have to do is plug in 1 in those parentheses there and type that into the calculator. So we've got 1.26 times 10 to the 9th. So that's 126 with 7 zeros behind it. I would move the decimal 1, 2, 9 times is going to end up putting 7 zeros behind it. Times natural log of 1 plus 8.33 times 1 all over natural log of 2. So here I've got it typed in. You can see all that typed in, and notice I've got the 1 plugged in there. And so we get this big long number, and so count how many numbers in front of the decimal. 1, 2, 3, 4, 5, 6, 7, 8, 9 to get behind the 4. So basically what we're looking at is about 4.06 times 10 to the 9th place. If you moved the decimal 9 times to the right, you'd be where we are on the screen. And so that's that many years. So if you think about a number with 9 zeros behind it, that's billions. So this is over 4 billion. Part B, same question. How old is a rock sample in which A over K equals 0.325? So it's the same formula, just fill it in. Here it is, and you'll notice really the only difference is instead of a 1 in this position, I put that 0.325 because that's A over K. And here it is typed in the calculator. Typed all that in. And notice there would be, that's going to be 2.38 times 10 to the 9th power. About. So again, we're talking about billions of years. About 2.38 billion years old.